Okay, welcome everybody. This is already the third language panel. We had one in PDC 2000, PDC 2003, and now. So what I would like to do is first introduce the panelists to you really quickly, and then the floor is open for your questions. And also I have my questions. I have like 20 questions that I would kind of like to ask these guys. So, but you come first. So, you know, anybody that has a question, just come up to the mic and ask it.
We have to answer his. We want to do it.
Please.
Okay, so from right to left, this is Jim Miller. Jim worked on Scheme in his previous life, and since he moved to Microsoft, he's been working on the CLR. Next one is Dave Thomas. In his previous life, he did Smalltalk and Forth, and also he is the brain behind Eclipse, IBM Eclipse. Then Paul Vick. Paul Vick is Mr. VB. Jim Hugunin, in his previous life, he did aspect-oriented programming. Fortunately, he has seen the light and is doing Python now. Then we have Bruce Payette. He used to be a Unix guy. You see a little bit left in his mustache, but the long hair is gone, but he's doing Monad now. And then we have a guest, last minute, is Rodrigo Oliveira. He is the implementer of the language Boo, which is a cross. He told me, and I kind of, you know, probably kind of mangle it, but it's a mix between Python and Visual Basic. But we can ask him, you know, later maybe. So, without further ado, please let the questions come. Anybody? Question, please?
The question I have is with respect to the difference in the implementation of JavaScript and the Iron Python approach, one being more strongly typed, compiled, the other being more dynamic. Sort of your ideas or thoughts about the difference and what you're planning to do with JavaScript, if anything, in terms of making it more dynamic.
Okay, Jim, this is a question for you.
Well, the first half of the question is for me.
Okay.
We'll figure out what to do with the second half.
You
of
just
the
pass
question.
it, if you don't know the answer, you just pass it to a random other.
Do we have a hot potato that we
Yes.
can pass around? Let's see. So the first half of the question. So Iron Python is trying to be an implementation of Python. And it's not trying to change Python to map it onto the CLR in any way. So it needed to have Python's completely dynamic compilation model. There really wasn't an alternative there. The other thing is it was a heck of a lot easier to do Iron Python and get it right when the CLR 2.0 came out. Key feature that the CLR added was dynamic methods and lightweight code generation that let you do some of the benefits that you get from this static compilation model in the fully dynamic sort of world. So Iron Python was able to finally get things right because it had the right infrastructure. As far as the plans for JScript, I don't...
Yeah, Jim, why don't you say, what are the plans for JScript?
I do not speak for Microsoft on this point. I can tell you a little bit about what I know is going on, which is that there is continued work in the standards, or JScript is standardized, and it's actually technically ECMAScript. And there is work in there on evolving the standard, and Microsoft is following that. There's also the work going on with Ajax and Atlas that we announced here, and we don't know yet where that's going to lead us with JScript. So we're sort of exploring that in that context. And so while I'd love to be able to tell you an answer, we just aren't far enough along yet to know where that's going to take us. It's kind of exciting because it's going to propel some more energy into JScript, which hasn't really had much motion. We've considered a stable, reliable product and haven't been evolving it much. I think it's going to look to see whether there's evolution that's needed to support that new use.
Okay, any more questions? Good, then I can start with my questions.
I have more questions.
Oh, you have a question? Go. Okay.
Tell us about Boo.
Yeah.
Yes, that's a good
I
question.
really want to know.
Okay. Well, Boo was actually created because I was really frustrated with the C# language. I was a C# programmer in a past life, and I had to type all that stuff. I had to code and to tell the compiler everything the compiler already knew about my program. I had to type over and over the type of my variables, the type of the return of my methods. And the compiler was actually pretty like a black box. I could not extend the compiler. I could not add new language constructs. And I felt like imprisoned in that kind of environment. And I had a short experience with Python before, like 6 months of Python programming, and I really got hooked up into the language, and especially the syntax. It just flows naturally. So, well, I decided to do something about it. I mean, I'm a programmer. I can do it, right? So I thought it was my job to fix that. So I decided to create Boo, and Boo is kind of like Python, C#, Ruby, and mixed together, right? With caffeine and ADD. So, so I started this project like 2 years ago, and now we have like a programming language and a extensible compiler infrastructure. The compiler works. First, I should tell that Boo is statically typed with type inference. We have all the features that C# and VB are now announcing, and we had since the beginning. And because it makes sense, and it's great to see these languages evolving. It was very inspiring to be at this PDC actually and talk to all these guys. And so you have this Pythonic syntax, right, with type inference to play really well with the other languages. But you also have like an escape to the dynamic typing word. You can write your own extensions to the type system with something probably similar to iReflect. I'm not sure what iReflect is at this moment, but I think it's pretty similar. So boo.codehouse.org, check it out, read the manifesto. If you believe in freedom and collaboration and that you want the power of a language that doesn't look down at you, so that's Boo.
Okay, well, thanks a lot. So let me kind of hook into this because you mentioned syntax a couple of times, and I know that Jim used to be a schemer, which has no syntax, and then,
It's got the same kind of syntax XML.
Yes, exactly, it has no syntax. And then, of course, VB is incredibly verbose, with all the keywords and so on, and then, of course, we have Python with the offside rule and so on. And then Monad has its own kind of, whatever, weird mixture of, Perl and shell language. So what is it with scripting languages or dynamic languages? Is the syntax, should it be concise? Should there be no syntax? Or should it be kind of, reader friendly with lots of keywords? So what are your opinions about that?
I'll start off.
Okay, good.
Let's see, first of all, white space needs to be significant or it's not real. I was hoping for some laughs out there. Clearly everybody doesn't know Python in the world. Python is, I believe, the only language in major use today, except for Fortran.
Oh, Haskell, don't forget
Haskell. White space is still significant. Haskell, sorry Eric, I keep forgetting Haskell. I want to say VB whenever I go to say Haskell these days. I don't know what's going on in my brain.
They're so much alike.
So I'm very much in the camp that the syntax needs to be succinct and short. Python programmers love to call Python executable pseudocode. And having that feel, and I think the vast majority of the scripting languages that people use, I mean, Monad has this feel too, has a very different syntax, but both languages have this feel of executable pseudocode for you when you look at it. And you feel like you're just writing, this is sort of what Rodrigo got to, you're writing exactly what you need to say what you want to get done, and as little about how it can get done as possible. There's extremes you can go to there, right? There's the APL world where it's exceedingly succinct and a very small number of people can understand it if you know all of the operators. And for that small number of people, it's the ideal language because it's exceedingly succinct. But I think there can be a middle ground where you can sit where it's just succinct enough.
Yeah.
Okay, good. So Dave, so you're a small talker, right? So that has even weirder syntax. So, well,
or perhaps a lot simpler syntax.
Yeah. Okay. So, but what is your opinion about syntax?
Let me just comment on that.
Yeah.
I think one of the issues for languages like Scheme and Smalltalk is that one of the things that they facilitate through their syntactic model is the ability to embed other languages, in particular support domain-specific programming. And one of the things that caused a lot of, for instance, engineering people and business people to be able to use Smalltalk is when they had a framework, they effectively automatically got a domain-specific programming language. And this is very popular in the scheme and modeling community. And so that's one of the strengths of a language which allows you this kind of effectively syntactic extension without having to go through very complicated machinery. Syntax, of course, is something that is a deep emotional thing, probably close to the emotion of whether you should use Emacs or an IDE. And these are the and so I mean, this is like basically if you play an electric guitar and someone gives you an organ, you're not really excited. So there's cognitive load associated with this, and one of the problems people get into debate about the fact that there's certain cognitive load. I mean, the whole idea of using column 7 and column 10 again, on like on a key punch, it sort of takes me away from Python personally and biases me as a Smalltalker to Ruby, because basically Ruby's just, Smalltalk with a sort of ugly procedural syntax. Right?
Smalltalk with a funny hat.
Yeah. So Jim, can you?
Yeah, I actually have a, I don't know, this is sort of like confessing to a secret sin or something. I have a mixed background. My first serious major programming language that I really invested in was a language called BCPL. Is anybody familiar with the BCPL? Yeah, you're as old as I, yeah.
We're all old.
So I took away two really good ideas from that I continue to like in the syntax domain. One is, well, actually three. So one is a recursive descent parser for two reasons. For the implementer, they're trivial. You can actually understand them. You don't need some stupid tool and some stupid other syntax and some other thing to maintain. They're just direct and easy to understand. But actually more importantly, they force the language design to be one that, while it's a tiny bit more verbose, it's never confusing to the user. It makes the cognitive load of the language unbelievably low. And so I work very hard when I'm doing languages that I designed. I did not design Scheme. I was a major implementer of it, but I didn't design it. When I designed languages, I did a variant of Dylan. I did the first Dylan that didn't have Lisp-like syntax, and I made it recursive descent. So that's my first comment. My second takeaway from it was a brilliant idea. I don't know who originated it. The lexical scanner of that language was sufficient to, in almost all cases, insert the semicolons and the word do where they were required by the syntax. So programmers almost never needed them, and it just had a clever heuristic that used white space. You'll be glad to know. So it said essentially, amongst other things, if you have a new line separating something that could end a statement from something that could begin a statement, put a semicolon in. And there's just two really clever ideas about how to do that. Made, again, the syntax the user saw simple, but the formal syntax of the language was still crystal clear and nice. And the third one, which I pleaded with Anders, I begged Anders, but he just wasn't in the mood. Don't make the stupid mistake that C and C++ made, which he did, which is not to reserve part of the namespace. With BCPL, there was a very simple rule that everybody knew, which is any identifier that's more than one letter long and is all lowercase is reserved for the implementers of the language. So when I needed to add a keyword, I had a fairly large vocabulary to draw from, right? And no user violated that. Now, the compiler didn't actually enforce it, which was kind of interesting, but it could have. But the net result was evolution of the language was simple. And we continue to make that same stupid mistake. I argued the same thing in the Scheme community in sort of reverse. I am not one of the people who likes macros in that community. And the reason is they introduce syntax, but they look syntactically like everything else. So you can't tell whether your piece of program is being handled specially. And there was no syntactic marker. So I argued very strongly, do something. Use square brackets, use squiggle braces, put a star in front of it, I don't care. But something so I know the difference. So those are my major thoughts on syntax.
So talking about keywords, there's a nice anecdote about C# and keywords. So if you've seen the C# 2.0, we introduced iterators. And first we had a new keyword, yield. But that was a new keyword. But then we had a brilliant idea to have two identifiers next to each other. So now it's yield return. So there's no new keywords required. But I agree with you, it's a little bit of a hack.
More than a little bit. Talk to me 10 years from now.
Yep. So Paul, talking about semicolons, what is this kind of crazy thing in VB with the underscore line continuations?
Pet peeves? Pet peeves, anybody?
Did John Hand be paid? Sorry, we have a developer who on Visual Basic who has been a long-standing a promise that if we would just give him a couple of days, he would be happy to take out the line continuations, and we may take him up on that offer. So what was the question exactly? Do I like line continuations? No, I mean they're a real pain, and basically, if there weren't a few syntactic ambiguities that we have to solve, I think we would have taken care of it a long time ago. They're not intractable. I would like to, and especially as we start to look at like some of the link stuff where you're writing now long select statements, and obviously with your work with XML literals, I mean the XML literal support we have at the moment in the prototype doesn't recognize. I mean you don't use line continuations. I think it's sort of an artifact that we can we have enough computing power now on the machines to be able to figure that kind of stuff out. So. But I actually want
the extra cores will be used for.
Yeah, exactly. We'll have a whole processor dedicated just to line continuation. But I did want to actually also add about the. It's funny, like you're talking about the keywords in reserved. We added a bunch of new keywords in the latest version, VB 2005, for operator overloading and a couple of other generics, and we just reserved them. And you have an upgrade tool, and really people seem to, I don't know, I think sometimes when we approach design, we worry about, the small inconveniences too much. I mean, there's the balance. It's like, you can't every version cause, huge amounts of pain to your upgrade, but then people do people can handle some things, and if it makes it better, if you don't have to add syntax just to create contextual keywords, that can be a benefit sometimes. So it's definitely it's a trade-off that you kind of have to try to find the right balance for.
So Bruce, can you tell us how you guys design the syntax of monads? So what kind of are your rules and heuristics and?
So unlike the other languages here, monad is a shell. So it's a command line interface. It's as much an interface as it is a programming language. And that adds a whole bunch of constraints to the design of the language. A big one being how much can you type in one line. So something like Python, where white space is significant, that becomes a real problem if you're trying to use an interactive shell. Although Jim does pretty well with it. A comment yesterday about Python's not just a shell. It does introduce a bunch of problems when you type copy foo.txt to bar.txt and you don't want to put quotes. Okay, so I can't have quotes all the time. I have to do bare word identification. We started with the POSIX shell grammar, which is essentially the Corn shell pre-88, something like that. And actually one of the people at Microsoft was the author of that, so he was involved in the early language design. But traditional shell languages work on the basis of doing expansion and then parsing. So you expand all the variables, you have a bunch of strings, you do quote removal, and then you parse it finally, which means all your variables have to be strings, and that's a problem if you want to be able to deal with objects. So that was the key variation in our language is, okay, we have a shell, but we're not going to render an object into a string until you actually want to display it. So this meant that we had to do a more traditional kind of compilation model. The other big problem that we're trying to get around is if you're, any Corn shell users? If you're familiar with the Corn shell, it has a billion little micro languages. So there's a language for doing comparisons, there's a sort of double paren notation, and there you're parsing an expression language, dollar squiggly bracket, and then there's a whole substitution language. So there's all these little languages, and actually command.exe has a lot of this as well. So one of our, and they're hard to remember, right? You have to go, geez, I'm using this fragment of the Corn shell, I have to go and look up the syntax for that language. So we tried to come up with a language that worked like a command line where you needed it to work like a command line, and worked like a scripting language where you needed it to work like a scripting language. And it's a little bit different, but our experience and feedback so far has been that it's pretty successful. We're pretty happy with the result. It's not as clean a language as like Jim Miller would like, but it's pretty easy to use.
Okay, good. And Rodrigo, do you have any comments about syntax?
Sure. A lot, actually. First, I should mention that Boo has a main syntax that looks a lot like Python. It's not as exactly Python. We decided to change a lot of stuff, actually. But the way we did is that the syntax is less important for us because we want users to actually customize the syntax or have other projects to spawn create their own domain-specific languages. So that being said, the Pythonic syntax is the one we actually use the most. Okay, but I have some comments about metaprogramming. Right, the gentleman on the left started touched the subject of metaprogramming, and I think that's one topic and one subject that is actually missing from all these languages right now, giving the users the power to extend the environment. And that is something that it's very valuable for us, for the Boo community. We have macros, but they are more like hygienic macros, but they have a very rigid structure, so you cannot really mess around too much. But we think that the compiler should not be above the user. You know, the user and the compiler should be at the same level. So your program should just flow naturally. If you want to extend the language, think of things like using the deterministic destruction stuff we have in C#, right? In Boo, this is just a macro. Okay, it's not a keyword. It's not in the compiler. It's just a macro. And lock, again, or synchronized, or whatever. It's just a macro, and it just flows. It's just in the language, so to speak. But you can extend and write your own keywords.
Okay, so.
Can I add
yeah, sure.
comment on following on along that? One of the things that's absolutely, boggles my mind and makes me absolutely delighted that we're coming out and talking about it, the PDC now is something that it didn't come from the scheme community, but we played with it for years, and it's finally hitting the mainstream, which is, and you mentioned it as well, which is one of the things those languages had, and I'm not defending their syntax, but their syntax had the virtue that you automatically got a syntax in the language for describing the main data structure of the language and programs in that language. Now, the fact that they were the same was perhaps more confusing than valuable, but we've actually starting down that same path in both C# and VB, because this XML literal stuff, well, that's the native data structure you'd like to be playing with, so making that something that you can easily manipulate in the language, that's half of it. And then if you look at the link stuff, that's building abstract syntax trees for new constructs in the language. That's getting us beginning down that line. Now, the question is, how do you do the Boo sort of thing of being able to say your own syntactic transforms based on those syntax trees? That's the next major step. The interesting question for me is, are we going to come up with an abstract syntax tree language as a library that we ship that's sufficiently powerful that all the languages that we're interested in can use that as the thing to which they compile, which all users then manipulate independent of language? And then you can transfer that skill from programmer to programmer and from language to language without having to relearn it in each language. If we can get there, that's a home run. Right now, in my opinion, we're at a triple.
Yeah, so this was exactly the question I wanted to ask. So like, in links, we have now these expression trees and meta programming. So Dave, can you give us any kind of advice about that? Or
First of all, I think the work that's being done in C# is interesting, but it's even more exciting for the VB community because basically most, I was one of the, Pied Pipers of objects, but most people can't do this. Particularly, they can't build frameworks, and class libraries are very hard relative to a lot of people who are actually trained in business or biology, which is one of the Python communities, for example. So one of the challenges you have in doing these really valuable language extensions is somehow also constraining the power and making it digestible to the audience that are going to use them. This is a real trade-off. Smalltalk is probably the penultimate thing of being extensible and has a fully open meta architecture and so on, but lots of people just can't gist it. And you can actually, the fact that you can change, maybe redefine what if means or something, it's really cool, but the number of people, so you really have to be very careful, when you go meta, right? You have to, you should have to sit on the carpet, you should have a little icon and so on, because when you start shifting language levels like this, it gets very, very tricky. And aspect-oriented programming basically shows what's happened with the failure of trying to do meta programming by trying to apply it into an existing language with very complicated tools and weavers. So you have to be very careful. So there's really this trade-off. I'm a huge fan of this extension mechanism, and it's really powerful in embedding new language. It's great in small talk that I can write an office application in French that says fichier ouvert, and it actually can talk to the folders in the natural language, because after all, not everyone programs it, and who's going to talk in English, right? So you can program. But on the other hand, you get so much power there, you have to manage and sort of give this power out. So one of the things we need to do is find some way to sort of have levels of language or things like that. But I definitely know you can run all these in a common infrastructure. And that alone would get us out of a lot of the problems. I mean, the horror we have right now is we have these different stacks with different execution engines, different compilers. And one of the reasons that all of us who are in industry are so retarded with getting new releases out is we've got so many of these things we try and got to synchronize. And it's just really hard. So to the extent that we can get together on common, simple LL1 parsing sort of technology, God, great mistake. I'll shut up at that point.
But I did want to add, too, that, I mean, it's interesting because, I mean, certainly in Visual Basic, we talk a lot about extensibility and accessibility of the language, because obviously we're making, we're talking about extensions for XML and that kind of thing. But the interesting challenge, of course, is it's like, I think about a fully extensible language, and it's wonderful, and it would be wonderful to work to have that. But then it's like, I think about the fact that, our full-time job is to design language, and we get it wrong so many times. I mean, we have to like work and work and work at it, and we think we've got it settled, and then we find some horrible mistake that we made. We got to go back and fix that, and and we get it done before we release. But it's like, I think it should be capable. It should be possible, but it is definitely not for the faint of heart. It's very easy to shoot yourself in the foot very horribly, as some languages have proven in the past. But I'm not gonna. Yeah.
Jim?
Sorry.
So I wanted to step in quickly and touch on the AOP thing for 1 second, which is, before working on AOP, I was a complete believer in metaprogramming, and that we needed metaprogramming for everyone. And AOP was actually an attempt, for those of you who don't know about aspect-oriented programming, the way that it fits into this context was it was really trying to cripple AOP and give you the smallest subset possible, smallest, safest subset you could, to still do some of the interesting things that people did with metaprogramming. And the jury is still out on even that small, safest subset, still saying, even that gets people into a whole bunch of trouble, because the number of people who can think in terms of the metastructure of their program is surprisingly small. I still think there's some potential use for it, but the other side sort of on the sales pitch is, the .NET framework and this whole common language runtime thing puts you in an interesting intermediate point, which is, it used to be if you wanted to design a new language with new syntax and new semantics and functionality, well, you do the language and that takes a year, and now you do 10 years building up the libraries and the rest of the infrastructure that you need to do it. And when you're in a point where it takes you just that 1 year to have the language, and at the end of the day, you're now done. You have the language, plus you have every library you could want in the world, plus support for things like LINQ. Now, some of the need for something like metaprogramming, I think, goes down.
Okay, so quickly, and then because we have now people lined up, so I want to give the audience a chance to ask their questions. So let's quickly, Bruce, and then we go to the...
Talking about cocktail party metaprogramming. That's what shell people do all the time, right? That's the tradition. Every time somebody writes a new command for a shell, you have a new language. And it's metaprogramming in the small. One of the things that we did in Monad is that there's a common parser for all the commandlets. So you don't have all this the wildly variable syntax. But we do still give you, people create macros, people create aliases, they've done it in command.exe, to give you a customizable environment. It's more of a user interface, I guess, than really a programming language. But there's a level of metaprogramming that people can do all the time.
Okay.
I want to touch on that a little bit, some of the complexity kind of things. I find it pretty easy with like strongly statically typed languages to write correct programs. Something like SML, like when it compiles, you kind of pretty much know it works because the compiler's forced you to be very precise about what it is you're trying to do. And I recognize that with dynamic languages, there's a whole lot of power there. But I'm wondering, is there a concern that that sort of thing makes it harder to write these programs? And is there realistically a trade-off then between that power and the ease of writing correct programs?
Okay, so yeah, Dave, Dave go first, and then we go, because yes, our dynamic language is safe.
The answer, of course, to a strongly typed person is no. That's the only I think you have building programs and how you build them correctly is an interesting thing. And if you actually look at test-first programming, which is the penultimate practice, which comes essentially from the Smalltalk community, right? Essentially, the whole issue there is you write a test, the test fails, you make the code work, you do that. If you're doing that, it's much stronger than a type checker, because a type checker does very little about the correctness of the behavior of the program. It just takes type signatures, right? Now, that's not to say that types aren't useful because of the guide you. And so the mixed strategy, which you see now people using of what's called soft type inference, soft typing really sort of gives you a bit of the best of both worlds. You don't have to carry the syntactic baggage. I mean, for example, rather than using something painful in Java, use an IDE like IntelliJ or Eclipse. They do tricks for you along the way so you can do this. However, it'd be much better if those were done by the language as they are in the new work in the recently announced work here than in the IDE, because you get tricks being performed for you that you have to understand later. So there's a trade-off, but the reality is we built and shipped embedded oscilloscopes, command and control systems, and we measure the defect rates and test coverage. And if I had a choice today still to build a system with a language like the kind of approach that's being used with VB and the C# approach, I think I would choose that, and I would probably use a lot of the other software type features. On the other hand, you don't really want to type every cell in your Excel spreadsheet. A lot of times you're thinking, so programming is problem solving, and there's a whole group of people who are not trying to build system code that rots and stays around for a long time, but are actually trying to solve problems. And they typically, when you're thinking, you don't know what the type is. If you actually knew what it was, it would be one thing. Once you know you're building a compiler, it's easy to say, I need an abstract syntax tree and type it all and so on. But when you're thinking, these types often get in your way and contribute to a lot of accidental complexity. But there's different styles, they're different instruments, they both make music. You need to understand the style and the culture of programming, just as if you go to use Unix or Windows, you have to understand the whole environment and how to do it. So I think it's dangerous to make statements.
Yeah, I'm not trying to
I'm trying to provide a balanced response on it, that's all.
Yeah, and I think it's pretty universal that a good programmer is going to write good code regardless of what kind of tools you're using.
I had just sort of two things to contribute to it. One is sort of what it is you're trying to accomplish with programming, and sort of the class. When I used to teach the introductory course at MIT, one of the sort of standing jokes we had was, which lasts longer, the pyramids or an amoeba? Right? Pyramids are strongly structured, well typed. We understand them. Amoebas evolve over time, right? They change. They're not strongly typed. They don't have boundaries. There's a whole big middle ground in the middle, too, right? Not many of us can make an amoeba, right? Lots of people know how to build pyramids. Somewhere in the middle, there's some interesting ground. And my own feeling is we're beginning, finally, thank goodness, to really explore in the mainstream languages that middle space. Because what bothered me, I came from the BCPL, which was untyped, not even dynamically typed, untyped. That wasn't good. Right, that one felt uncomfortable. I loved it. I mean, it was really nice, but it really wasn't supportive enough for me. And I went to C, and that was a little too strong for my personal taste, but it wasn't so bad. And then over to the Scheme community, where there's no syntactic typing, but there's dynamic typing at runtime. So, your program might fail while it runs. That's what all, the strong type people complain. Oh, but your programs can fail when they run. And my answer was, and yours throw no exceptions? You never, it's absurd. The type system doesn't do that. If a type system did that, it'd be wonderful. It's also provably impossible, so too bad. So you're in the middle ground, right? And types were, for 20 years, the best middle ground we could find. And then ML really pioneered this, let's figure out the types so the user don't have to type them all. And there's this interesting middle ground. I think we may have gone a little too far to the loose side right now, where my belief is what a type is there to do is to get me to understand what my program is doing. And so I write the type down in some cases and have the computer check that that's the type that it's doing to make sure we're in sync. Right? And I don't mind if the computer figures out all the simple types where I don't care and deduces them and stuff. But if the computer's deducing types that are so complicated that I would never have dreamed of writing them down, maybe there's a mistake here. Now, the interesting thing is when you look at LINQ, you're in this bizarre situation where the types it needs to build for these intermediate expressions are ridiculous and you could never possibly, even if you could, sometimes you can't even write them in your own language, there's no choice, but even if you could, you wouldn't write a type that big. But then you actually never do anything with it except extract the piece out of it that brings you back down here and here and here, and all of a sudden it collapses down to string, which you know and love, right? So it's not a bad middle ground, and I think we're approximating a place that I think I'd actually love to do a lot of programming in.
So Paul, can you comment a little bit about this middle ground?
Yeah, sure. Yeah, I mean, I think that's kind of, I mean, Visual Basic kind of lives in that. I mean, we started, you know, in the old days, we started at the sort of much more dynamically typed, you know, variant world, and then with .NET, we swung way back into, you know, you sort of have as I kind of said, you know, we sort of have this canyon. On one end, it's like option strict on, everything fully typed, option strict off, nothing typed, and what we're trying to do now is kind of fill in the big valley between the two so that you can make that kind of solid progression. And I think, you know, in some ways, I think, especially with the mainstream languages, you end up with the sort of mistake that we make as programmers a lot of the time, which is, well, if we can't solve the problem completely and completely correctly, then let's not even try it at all. And it's like, you know, and so that's where you get these big, you know, valleys. And I think that, you know, as we start to look at the problem, it's like, well, you know, we can solve, and Visual Basic a lot of times is about this. It's like, well, if we can solve it right, you know, most of the time in a way that's understandable to people, and it kind of makes sense where, you know, okay, all right, here it's not going to work, but I understand why it's not going to work here, so that's okay. Then I think we can, you know, really, we may not be able to cover a 100% case, but 90% makes people's lives a lot easier. So.
And Jim, what about Python? I mean, I read on Guido's blog that he wants to do kind of type inference as well and so on. So what's your opinion on that?
Yeah, I made the mistake the first time I came to Microsoft of saying, you know, my general strategy of programming, and, you know, for building the IronPython compiler, for example, I wrote the first 3 prototypes in Python because this is back to the I can think so much faster and get doing what I want to do. And then, I mean, Dave sort of captured the story just perfectly. And then I moved it to C#, which happens to be my preferred strongly typed language. And what I would have really preferred to do was to say, no, I want to go through this Python program and add a little bit of information here and there that says, okay, now I understand some static things about the structure of my program. I want your help in going through the structure and annotating it. And, you know, that's what I was looking for, was a language that could do that. Somebody mentioned to me we have this language called VB that would do that. And,
who could that have been?
And I found it didn't go down far enough on the dynamic end, but I think it really is, you know, it's great to see a language sort of pushing in that direction, because that's the development experience that I'd like to have. Because at the end of the day, I want those types, but also I've written a number of programs in ML, and I find that, you know, it's often I spend 3 or 4 hours at the whiteboard figuring out what the structure of this type system is going to be before I can start writing down code sometimes. And, you know, in Python, I start writing the code for 3 or 4 hours, and at the end of 3 or 4 hours, I know what the type structure was that I wound up with. And for me, that's a lot more enjoyable experience. If I could then put those types in.
And by the way, the IDE is a big piece of this too, because when you said you want to add them in, it's nice if you add them in, the IDE either automatically fixes the places or points out the ones. Without the IDE, like, you know, much as I love Emacs, when I try to do this stuff in Emacs, it drives you nuts, right?
Yep. And I also read in some of the Monet white papers that they think Monet is like, you know, something that can bridge between the dynamic types and static types. Can you comment on that?
Right. Yeah, currently we don't do a lot of static type checking, but we also allow you to annotate your code with type. So you can say the variable is this particular type. You can use casts to convert type, because type's very important in Monet, right? We're an object-based shell. We want to be able to deal with things on a type basis. And so, yeah, you can be quite rigorous in how you specify your programs. Not sure what else to say about that.
Okay, so shall we kind of wait for you, and then let's take the next question here, and then, you know, we start with you to answer the question, whatever the question will be, just to surprise.
One quick comment and then a question. The comment is that back to the statement that someone made up there that was a little deprecating of the application community getting into trouble stepping on its foot if they're giving access to a lot of dynamic extensions at runtime. I would just say that if the development community in that particular area has a strong meta model of what it is they're trying to accomplish, I think the likelihood of getting into trouble is no greater than it would be in, using a conventional static environment. And so as our experience has been in selected areas of going much stronger towards model-driven application frameworks, we want to have more dynamicity. We want to push, we now know what we have in the metadata, and we want to be able to then push our implementation frameworks to occur at runtime, no longer at compile time, at classic compile time. That was the editorial comment. The question is, it follows up on the comment you made about the importance of the IDE, and I was just wondering, it seems like a lot of times with languages, and both dynamic languages and non-dynamic languages, the basic language designer gestalt is formed around arguments about what they're seeing as far as ASCII streams go on the screen, what you're typing, what you're seeing. I have to say that as I've gotten older and my memory stack of what I can remember about any language is getting smaller and shorter, I'm finding that the value of using richer and more capable IDEs becoming more and more important. I spend about half my time doing Java development and about half doing C#. And if it wasn't for Eclipse and its IntelliSense capabilities and Visual Studio and its IntelliSense capabilities, I'd never get any coding done because I just wouldn't be spending all my time looking up things. And then the ability to do little mini organizations, so being able to fold, have fold sections in the coding. This kind of stuff that you don't even think of as classic language design is becoming more and more important in my life just to get productivity done. And I was just wondering, as you think about language design and going forward, what about the importance of the cognitive aspects of what the programmer's user interface is into the language as against just the language itself and its semantics?
Okay, so Rodrigo, did you design Boo with IDE and so on?
Thank you. Yeah, that's a great question. And the comment, yes, power to the people, man. Power to the people. Well, it's great that this question actually allows me to answer the two questions before that I wanted to answer. The problem is information overload, Talking about metaprogramming and IDEs, how many times do you have to validate arguments to a function? If argument is something, then raise or throw or whatever is the keyword in your preferred language, exception. How many times do you have to type get, set, and whatever? How many times do you have to type to create a simple, strongly typed collection or whatever? How many times do you have to implement a observe a design pattern or whatever design pattern? And okay, the IDE has this nice thing called code snippets. Great, I don't have to type it anymore, but I have to read it over and over and over again. It's information overload. And you have all these languages with all these symbols in the language getting in the way. Information overload. They're not there to help you. They're there to help the compiler. So metaprogramming for me is very powerful in that way that you can encapsulate this code, these microcode patterns you write over and over. And you assign a beautiful name like, okay, this parameter is required. And you annotate the parameter. You say it's required. And you say, okay, this is a property. And you say, whatever, So for me, IDEs are about being productive, but after the language has actually made its homework of getting the information, the right information to you right, I think that's the point. And about static versus dynamic, I think static type systems are there for a reason. Boo is statically typed most of the time. And for me, the reason is to help the compiler generate the best code it can, to play along with all these languages nicely, and to allow tools to be better tools because they can analyze the code. But I don't care. I care about the behavior of my program. My users care about the behavior of my program. And the way I approach programming is that I write tests to ensure my programs work. So
static typing or strongly typing don't give you the right behavior. It's the way you approach programming that gives you the right behavior. Okay.
So Dave, can you say something about IDEs as you know?
Well, I guess they're kind of needles for addicts. One of the reasons that you need a sophisticated IDE like Eclipse is because Java, the whole Java platform is so bad. Fundamentally, some of the reasons is there's just a lot of stuff. There's too much stuff for most people to be able to gist, so you need these browsers with these large libraries and things like that. So there is a reason, and you do definitely need these tools. But on the other hand, if you had more expressive languages, in many cases you wouldn't need a lot of this sort of machinery. If you would take a look at dealing with data, for example, since that's been brought up here, look at all the goop you go through to basically, persist and take an object that you select most programs are CRUD, right? Basically, you select from the database. What you do is you race the garbage collector to create, objectify all these records in memory. Race the garbage collector. You get 10,000 of them. You're running out of RAM. That's in swapping. Then you select 10 of them. Then you serialize those into XML so you can waste some more CPU cycles. The world's longest print string. If you send XML to an object, there's no longer print string you can get back. And then you send it to a browser and do the same thing. This is brain dead. It's just a dumb idea. The object guys got data wrong, right? And the whole point of trying to bring these new ideas together is so you don't have to copy the thing 20 times. So you don't have to learn how to swizzle it from here to so you use some stupid OR mapping thing that you always get kludged up one way or the other, suffer huge performance problems. A lot of that complexity, which you used, magic tools for now, model-driven architecture, UML, all this stuff is really there because the fundamental stuff below is just too complicated. On the other hand, I do agree that IDEs should help you do the things that you need to do, but in many cases, the old idiom is if you need really smart tools, you must be working with a really bad platform. And I think one of the messages here is to try and lift the language level so you can do things simpler at the language level so that the kind of tool support, I don't want an AI system inside my tool to try and figure out, that means that the computer can't even figure out what the program's for.
Can I add something there? Because it's kind of, although I'm not sure how I could follow that.
He's too good.
I know. I'm regretting saying anything. But the interesting thing for Visual Basic, in a lot of ways, if you look at what the traditional Visual Basic kind of application is, it's this client application, and for them, for a lot of Visual Basic programmers, the IDE is the language. I mean, they don't think in terms of, because language is a fun computer science thing, we think about all the different structures. But for a lot of people, the form designer is where they live. They design their forms. They put a little bit of code behind it just to wire things up a little bit. And so, the IDE is as important for a lot of programmers. It's sort of like you sort of have the triumvirate. You have the language, you have the IDE, and you have the libraries. And it's sort of like we like to focus on the language because that's really fun. But and I think you were totally right. Not just the IDE, the libraries as well. I mean, that moving to .NET, part of what made it so hard for Visual Basic programmers was just that they went from this nice little contained world, where yes, they had only a small set of libraries, but they knew where everything was. And now all of a sudden they're in this huge department store with no map, and they're like, I just want to do the thing I was doing yesterday, but I don't even know where to find it. And so it is sort of this. I mean, and I don't think we should go back to a world where you don't, you cut out 2/3 of the class library because there's so much useful stuff in there. But it's make a shorter book for Brad Abrams. The library reference could be like that thick. So
Tim?
So sort of following up, I want to do a bouquet and a brickbat here. The brickbat I'm going to hurl at somebody who's fairly near me, but they did it a long time ago, so you can't blame them. Mr. Small Talk. I think the bad mistake to make is to say my interactive environment and my program are one and the same. Interlist made the same mistake. You can't print out your Smalltalk program. I just can't do it. I went to these guys and said, "Show me my program." After I wrote something, they said, "Well, it's there. It's in that workspace. Well, I know it's there, but Where is it? You can't get it back out. The same with the interlisp stuff. It was so deeply embedded, you couldn't figure out what was yours, what was theirs. And by the way, if I wanted to, I had this problem with the interlisp system. I don't know if any of you people know it, but it had an AI system for deducing when you misspelled things like that. Well, for today, it was a really nice supportive system. And a guy named Dwim, do what I mean. Warren Titleman wrote that. And Warren, I've never actually met Warren. I would love to do it one day. He and I think alike. That's nice and bad. The bad part was that he would use variable names that were the same as the variable names I would use, and he would win. And so my programs would do things that no one in their right mind could imagine them doing, because somewhere deep in the system, Warren had used the same name I had, and his binding won over my binding, and it was just nutso. So that's the don't do your IDE that way. The ones I'd like to throw the bouquet to is the VB team. I think par excellence. They are the ones who thought, how does the language and the IDE together make an experience for the user? Now, I don't think they did it perfectly, but they're the best I've ever come across. I mean, it's just unbelievable to me. They will make compromises in the language design that as a language designer, I'll go, well, that's, interesting design choice. And then I'll look at the user experiences. Oh, I get it. In the IDE, that makes absolutely perfect sense. And you can still extract your program. You can look at the VB program. You can understand the whole darn thing. It's really nicely done. And the one place I disagree with you, but I don't think you intended it. It's probably just the way I heard it. I think the libraries are so fundamentally important. I may agree.
Oh,
and
sure.
they've got to be that big to be that useful. And you can't deal with that larger library without the IDE tool support. So the one place where you can't say it's a bad language because I need the IDE is when it's not the language that's forcing the IDE, it's the ability to understand which parts of that library focus your attention. I can't write a program in any modern programming language without that stuff. I mean, the IntelliSense style of thing is phenomenal. I never had this problem in Skiing because we didn't have a library big enough to shake a stick at. And when we started building stuff up, it became the same problem. You couldn't find anything. So IDEs for that purpose and for supporting, but I agree, if it's an AI system in the IDE, there's something fundamentally wrong.
Well, I mean, it's kind of like, with Visual Basic in the current version, we had this sort of my thing, which a lot of people, look at, but it's kind of like, it's like, you get to learn your neighborhood first. Then, you get to all the important thing, all right, I know where the store is, I know where to get food, I know where to get gas. And then it's like, okay, and then once I've learned my neighborhood, now I can venture out into the city as needed. So anyway.
So Jim Hugunin, I have a question for you about the kind of, IDE. So first, you showed this very cool kind of tab completion while you're running in your REPL loop. But if I write my Python program like in the IDE, then how do I get IntelliSense and how can I kind of navigate the class libraries?
There's a line of 3 people asking questions there. But no, so I mean, the one thing that I'll say, I wanted to take that the other way. I wanted the question of, you can't get IntelliSense in dynamic languages, but no, the interactive REPL loop shows that you can actually get them extremely well. And the cool thing about working with it interactively is you can get IntelliSense on top of things that are things like XML queries, or working with the database. You can get IntelliSense to work in your dynamic language where it would be extremely hard to get to work in a classic static compiled world. And the reason that works is you're playing around with live objects. You can go out and ask the live objects things about their state and therefore find out everything you need to know. So there's a certain environment where you get much richer notion of IntelliSense support. Inside of the static IDE, there definitely are some limitations. And today, there are very few dynamic language IDEs that do that sort of thing well. There are tricks that you can play with notions of type inference, where you go well beyond the single line kind of type inference that we've been talking about today with LINQ. And you do things over the whole program. Dave can talk to this more accurately probably in what they've done in the Smalltalk world. But some Smalltalk IDEs have played games with this to do a little bit of this sort of completion effectively. I think Smalltalk ones are the only IDEs that have done this effectively. The only dynamic IDEs, language IDEs that have done this well.
There's quite a few people that have done it, but certainly the Haskell Haskell community, ML Haskell community has a strong tradition for doing that. It's been done in the functional community. It hasn't been done much in the popular scripting sort of.
Right. So the popular scripting language hasn't done it. I think it is a hard problem, but it's one, as we're moving towards more and more dynamic data types, it's one that all the languages, I think, are going to have to solve. And looking at some of the things that I saw Paul talking about with VB9, where you're talking about being able to do things like, tab completion on XML fields again. Well, now you've got to do a little bit more of this type inference and interacting with the runtime system in order to get this to work. And you're coming at the problem from the other direction. But both languages sort of, I think, wind up at the same place as to the kinds of features that you need to provide that sort of rich support. So it's a hard problem, but we're all going to get to solve that one together.
Okay, so quickly, Bruce, and then we'll go to the next question there.
I just think everybody thinks about an IDE as this big graphical thing that you click around on. And it's not, it's an environment. I mean, there's a really good paper published in IEEE Computer like 15 years ago talking about two programming environments, the hot new programming environments. And one of them was Interlisp, and the other one was the Unix Programmer's Workbench, where you have this set of things where you're in an interactive environment, and you can discover stuff about your environment. With the .NET Framework and in Monad, you can use the same set of tools to discover all kinds of things. If you write a function, then you can find out what functions you've defined in this environment by listing the function directory. You just type ls function : / you see all your functions. You want to see your variables? Same thing. They show up as a drive in your environment. What type is it? I can ask it what type it is. What methods are defined on the string? I can just ask the string class. Because there's so much information in the .NET Framework, it gives you this really interactive integrated development environment. Once you're done creating your set of functions and so forth, you want to dump into a file, you just write something that iterates over the function drive and dumps the text, because you can get the text back from all the functions, dump them into a script. Boom, you're done. Right? You've been able to save the work that you've done in your interactive session. If you only want to save part of it, you just start a new scope. Now all my functions are created in this local scope. I don't pick the things up out of the global scope, and I can capture that entire environment, all the local functions, all the local variables, still interactive, and dump it out. So you don't have to constrain, you don't have to think about an idea as just being this big GUI thing.
Yep. I agree with that.
Okay, basically I have a comment, like I've worked with languages, etc., and the thing that comes quite often is I work in banking industries and they say, well, we really like to work with it, but we have this language, business language, that's our own, we like it to be like that. And I find that most languages, they don't allow me to go and say, okay, here's a BNF, I want you to compile this, and give me access to the AST tree, so I can navigate and extend it, really. And look, when we see the LinkQ project, we're all excited about it, but this should have been available long time ago. Like, hey, people access the database, they want SQL, well, okay, here, you're gonna go and do it. We know how to access the person's database or whatever, we know all that stuff, and we wanted to make sure that when we access it, yeah, you have your database connection ready all at the time, not at runtime, because we wind up throwing exceptions and writing garbled code that is nice to catch at compile time. And it's, I think we need to introduce that into our languages, allowing developers to know what they do and extend it. And
since I'm not from Microsoft, I want to speak on behalf of Microsoft on that problem. Because this turns out to be making XML and data and rows. People from the row world and people from the pointy world get together, and unifying that into an existing language, is an extremely challenging language design problem. And Microsoft is just fortunate to have a team of people that have the kind of background in machinery. You get this funny functional guy over here, and these people that actually understand how normal people actually do things. People in the CLR. So I think they're doing an amazing job in putting this in, and I think it really takes a lot of guts to actually go in and open up the languages the way they have with the next version. And I think that's very progressive. And this is a very challenging design problem to do this. It's a very challenging implementation problem. It's distinctly non-trivial. But it will mean, that you won't have to use a lot of this complicated machinery now, all these class libraries, for this specific problem, because they will actually be solved by the language, which was really what my previous comment was about. That often a small, well-thought-out language decision will eliminate the need for a whole lot of tooling and classes and so on, because they will be used underneath transparently to the person who's writing the application. So, Microsoft.
Okay, next question, please.
This is sort of a simple-minded question here, but I moved, I've been programming in C++ for my Sims. And, when I first saw the C# and started working at it, one of the first things I noticed is, oh, only one type of string. Ain't that wonderful? Because every time I need to do anything to a string, it was always with some other type of string that I had currently. And I spent 90% of my time turning my character arrays into C strings, into LPSTs, into string type, into whatever. And of course, anybody else who was working on a class, they always passed something that I didn't have into their functions. So I said, oh, great. C#, one type of string, that's wonderful. They have nice rich set. And now I've seen it starting to fade out. And, you know, it's spread out again. I'm starting to see different types and different, or untyping, that now we can't use the same thing all the time. I'm wondering if, what direction things are moving.
So can I add to your question? Because that's, for example, we now have like CLR objects, Python objects, monad objects, probably Boo objects, which are all kind of, you know, similar but different. So it's like the strings right now. Suddenly, you know, Python creates an object, but it's different than the, you know, the monad object. So
I think I have two or three different types of booleans. I mean, as far as I'm concerned, Boolean is a, you know, on, off, yes, no. There's only two possibilities. But half the time when I compile it, it says, oh, you're being forced into it, you're forcing into a different type of Boolean. How can you have a different type of Boolean?
I honestly don't understand what you're referring to.
I do a compile, I get a warning message. It said, you're forcing this Boolean into a different type.
So,
don't know why.
Okay, so but let's take the question to the kind of original one, right? So what is this problem with kind of, you know, the different, like, you know, objects for the different languages? And this kind of goes back also to the I reflect or whatever. Mm-hmm. So can you comment on that, Jim?
Sure. So I'll take the broader one of the one issue with having multiple languages. Kind of, I made this point earlier when we were talking about metaprogramming, which, you know, one of the great things about the framework is that when you come up with a new language, you don't need to come up with all of these new libraries. And, you know, that's certainly been the point of view with IronPython. Is in, you know, in IronPython strings, there are some differences between Python strings and CLR strings, but they're the same object. And all, you know, Python strings are represented by CLR string objects, and it's the compiler's job to make sure that to the Python programmer they look like Python strings. But if you pass it off to a VB program, it's going to look like a VB string, so that we really don't have this proliferation of different types. And that's true for all of the framework types. You know, everything that you're working with in IronPython is a framework type. You can extend a .NET interface with a Python type and pass it to somebody who wants that interface, and it all sort of interoperates exactly the way you'd want it to. Now, the one case, just to stop your question, the one case where that doesn't work 100% today is these dynamic languages do let you dynamically add methods and fields to objects at runtime, which is something that the CLR as a whole doesn't know about today. So in Python, there is a Python object type. And whenever I have a new Python class, it might subtype some CLR classes, but it adds in this Python object interface that says, yep, you know what, you can stick arbitrary things on me, you can change my methods at runtime, you can do all of this cool dynamic language stuff. And that all works great only within the Python world. And the frustrating thing is, you know, in the monad world, it's also possible to do these kinds of dynamic things to your objects. But if you pass this Python object to the monad world and you try and do it in the monad way, it's not going to work. It's going to say, I don't understand this Python object, and vice versa. And in the Boo world, there's another way to go ahead and annotate an object to say, I can do some dynamic things to it. And we're hoping that that'll be true in the VB world. And the whole point of the common language runtime is, you know, where we need to move to next is providing a common set of interfaces here so that when languages enable this functionality, they all do it in the same way. So that now these objects that have this additional layer of dynamic functionality all do it in a way that everybody can share and work with, and we can all get along.
Yeah, and sure, the dynamic, certainly for what we're doing with Monad, we have a couple of reasons for using these dynamic extensions. And what we're typically doing is not designing new types. We're doing something to an existing type, largely because it didn't do quite what we wanted. In a lot of cases, if you're trying to use it from the command line, you don't want to type something that's like 400 characters long to get a property name. So we give you property aliasing to give you a short property. The other thing is we're trying to paper over some of the inconsistencies. So on an array, you get the length of an array with the length property, but on a collection, you get the length of the collection with the count property. So we have these adapters that let you say dot count on everything, and it just works. We also do a bunch of we also give a common presentation of other data types. So VB is adding the ability to use XML objects as objects. We have something like that in Monad as well. You can take a fragment of XML text and just access the properties and step through all of them. You can do the same thing with a WMI object. Since we're in the management space, that's really important. The native .NET way of getting a WMI object is object dot get member double quote name of member close. It's very it's not a very friendly syntax. So we adapt that. Similarly with COM objects. But as Jim said, having one way to do it, we wouldn't have had to invent our own thing. He wouldn't have to do his adaptation because he has to adapt some of the Python. Python has existing names for certain properties on classes, and .NET has different names. I'm sure Boo has a similar kind of deal. Well, you started from scratch, so you didn't have the inherited property of another language.
Exactly.
So Jim?
I had sort of two comments. One was that I'm on the Common Language Runtime team, so from my point of view, they're all just objects. I don't know what you guys are complaining about. You can two-string every one of them. Right? So,
well, if it's overwritten, yeah.
Quite seriously, there were two parts to what we did in the first version of the runtime. One was to make sure that we had a common representation that everything could map to. The other one, which I really want to give credit to Brad Abrams, because he started and ran this process for years, was the common language specification, which was an agreement of a subset of all the stuff that was being built that all the languages would do, that forced changes in some languages and forced some compatibility issues in the languages, would solve precisely the issue you're talking about here. And I think we're ready to do the next round of that, which is probably not CLS, but CLS for dynamic languages, because it won't impact the more static languages. But this is the standard way you're going to do it for these class of languages, and it's going to hurt the same way the first round hurt. It's going to mean that one of you two guys, or maybe both, will wind up changing what you're doing with objects, or fear the fact that you can't interop. And the thing that will drive that is where the customers say, we are writing things where we need to use Monad to automate stuff written in Python, and your object models, you're both extensible and you extend the wrong way, and fix it, guys. Or where they just say, well, that's fine, we can deal with it. I don't think the cards are in yet on that one. But I think that's sort of if you ask me where we're going, I think that's the road we're heading down, because we're heading down to being serious about dynamic languages the same way we were about the static languages. We're going to do the same kinds of things another round.
Yeah. Got to hurry up, though. We need to ship.
Questions?
That's why it's going to hurt you, because it'll be after you guys ship. If it's before you ship, it doesn't hurt.
Okay, got two questions. First question actually should be pretty easy, hopefully. We all know pretty much what your first favorite language is, so why don't you tell us what your second favorite language is to work in? And let me give you my second question, then I'll go sit down, because I imagine this one's going to be a long one, hopefully. There is a feature in the languages that we don't have. It was brought up actually at Paul's session yesterday morning. I don't know if we want it, because I don't know what it's going to look like or how I'm going to use it when it's there, if it is. How about multiple inheritance? I'd like to know what you guys think about that. So I'll go sit down. Thanks.
Okay, so let's do the first question first, from left to right. So Rodrigo, what is your second favorite language?
Python.
Okay. Bruce?
Probably C#.
Jim?
C#, although I'm hoping you're going to change my mind and I'll say VB.
Okay, good. Next time I expect from both of you VB. Paul?
Oh, God, that's a good question. C#. No, I'll actually I'll make Erik stay here. I'll say actually Haskell. Because actually the ironic quick story was that in my college career, one of my professors was Paul Hudak, who was one of the Haskell founders. And so I took his compiler class, so we did it in Haskell, which was very interesting to write a compiler in a fully functional language. And I don't know that I learned a lot of things that I apply now exactly, but it was certainly the most beautiful compiler that I've ever written. It just, anyway, so.
Good choice. Dave?
J.
J.
APL without the weird symbols.
And Jim?
VB.
Good, good. So it's getting there. So okay, and so the second question, multiple inheritance. I think Jim has something to say about that.
Which
Yeah.
Jim?
This Jim. This is Jim.
Oh,
this Jim.
We're never going to do it unless the CLR supports it. Not that I'm asking to do it, I'm just saying, you know.
I'm going to throw out the same idea I've been throwing out for 5 years and getting nowhere with, which is I don't believe that full multiple inheritance is actually the right way to go for a whole bunch of technical reasons. But I think the fact that on interfaces you can't provide default implementations of virtual methods is just screwball. If you could do that, almost everybody I've talked to says you get about 90% of what you get from the full multiple inheritance model. You get the ability to provide a much, much easier experience for anybody who uses that interface, because if you can define these new methods in terms of the old ones, or in terms of one thing the customer has to supply, like one piece of state that the customer has to supply, and you just say that's a private a protected property and you must implement it, you get so much power in your language. It's phenomenal. Now, you might ask, okay, given that I felt that way and I felt that way quite strongly for 5 years, why don't we have it? The answer is, I can't convince these folks and the other guys that it's worth putting in the language. If you don't put it in the language, why put it in the underlying thing? You might get it wrong and nobody's going to use it. And we're in a chicken and egg problem. So until we can convince the languages, I can't convince the runtime to implement the feature. And the languages tend to say, well, we don't have the feature, so we can't implement it, right? So I think the world's screwed up, and I think you guys should fix it first.
Well, so speaking about fixing it from the language point of view, so Python, the language, has multiple inheritance. So obviously IronPython has multiple inheritance. And the good news is, great, you have multiple inheritance between all your Python classes. And I think that's very useful. And the bad news is it's implemented under the covers. Oddly enough, there is no multiple inheritance under the covers. So it's implemented in a way that it's not exposed to any other language. And people really can't share that experience effectively. And there's some performance issues and some other potential issues in the way that it's done. But it gives you multiple inheritance to play around with at the language level and to use it there. And that can work very effectively for a lot of what you want to do.
Yeah, and Monad's very much similar. We're a little stranger in that you can just inherit a little bit from something. Right, so I want these two methods on this one and that method over there, and I'm going to make them another one, and I want to make this thing still act like one of the base classes. So we're very dynamic in that respect. But our implementation is different than Jim's implementation, and so yeah, having some kind of common specification that supported that type of semantic would be incredibly useful.
Okay, and Rodrigo?
Well, one goal for Boo is to work nicely in the CLR. So the CLR doesn't support it, we don't support it. I'm a long time C++ programmer before getting in touch with Python and Boo. And I don't miss, actually, multiple inheritance. I miss like mixing inheritance, pretty much what you talked about. And I think that kind of thing should be enough.
Yeah, so the funny thing is, if you look at Eiffel, they had multiple inheritance for a long time, but now they've added mixed-in inheritance, and I think Bertrand thinks that that's better. So Dave?
Yeah, I mean, the general accepted thing in the object community at the language research level is that something like mix-ins or a refinement of interfaces is what's needed. But the other experience, getting myself in trouble again, that there are normal people that find object programming challenging, is that the more machinery you add, I mean, you take generics. We've never built a class library significant. We have very little significant experience building class libraries with generics, but we got them. We add multiple inheritance, and certainly the experience from the Lisp community in languages which had them, or languages like Self, which you can have any kind of left sideways or whatever inheritance you want, because it's totally prototype that, is we don't have much experience actually using these to build significant libraries or applications. So one of the challenges is before you introduce a new mechanism, you'd actually like to have someone build some significant amount of code to see exactly what that means. And I'm not sure we know exactly what we gain for when we add in some of these more complicated forms. I mean, I personally like the idea of mix-ins, but on the other hand, I've lived for a long time without them.
My question's really kind of quick and short. Actually, I think it's for Bruce. Is your name the Monad guy? I went to the Monad conference, and I think I've drank all the Monad Kool-Aid that you can drink. I'm really actually very excited about Monad and what it lets you
It
do.
seems the Kool-Aid seems to be bad for
Yeah, but the question I have is, and don't take this the wrong way, but is Monad being built on a 100% like ECMA CLR standard? Like, is it going to run on that? Because one of the things that I'm excited about is the Mono project and how it takes it, to Mac and to Linux. And I'm actually a Linux user at home, but I want to be able to use these tools. Are you guys going to do anything so that to make sure Monad will run on any of those?
We're not taking any dependencies on anything that isn't in 2.0 version of the CLR. And the Windows-specific stuff is in a set of modules. That said, we have no plans currently to bring it onto any other platform, but I have a Mac at home. I wouldn't mind seeing it there. So there's nothing that should really forbid running it on a compliant implementation of the CLR.
Okay.
But it's not been one of our goals so far.
Cool, thanks.
Next question.
So I'd like to solicit a question, your thoughts about the future of languages in regard to multi-threading. As it stands right now, I find it's quite difficult to write a program that properly takes advantage of multiple threads. And the multi-core CPUs is the buzzword right now, and we talk about quantum computers down the road. So it would be nice to have something like imagine select case in VB or switch statement in C# that says, hey, here's 5 blocks of code. Please execute this in parallel, and at the end, I'll continue without resorting to all those rather difficult syntaxes that's right now. So what's the future in that regards with dynamic languages?
Excellent question.
Yeah. I won't talk about the future. I'll tell you about the past, though. That's my. See, to me, a friend of mine who's actually a professor, he used to be a curator at the Smithsonian and studied history of technology, says computer science is the only one where he can accurately predict the future, because he turns the clock back 20 years. Sees what was new then, but didn't work because it wasn't fast enough. Because that'll be invented this year. Right, so.
Right, it's like there are 15 basic ideas in computer science, and we just discover them every 10, 15 years.
Yeah. He claims the clock cycle's 20 years,
Exactly,
but it's 20 plus or minus 5. So my PhD thesis was on parallel programming, and I believe we're going to reinvent a lot of what I did and other people in that era did, which is we're going to rediscover data parallel programming, and we're just going to decide that, by God, that's where the vast majority of the interesting parallelism on the server is. And no comment about what's going on at Microsoft, because I honestly don't know. I really mean that. But if I were running things here, I would say, golly, isn't Link a good step in going in that direction? Because it makes the programming model completely hidden, and it's all under the covers right where it ought to be from the customer's point of view. So I think that's going to happen. The other thing we did was we worked on this thing called the future, where you say, go do this computation, give me something I can hold as its value, but keep the computation going. And only when I go to actually access its value, then suspend me and wait for it. Boy, that's a programming model I can understand. Doesn't work well if people are doing lots of side effects. Better start moving towards functional programming styles if you want to do that one. But that one's really nice, integrates beautifully into programming languages. But I think there's some real fertile area here. The only thing that I don't think we have covered in the CLR at the level of the system I deal with, see, all that stuff can be done on top of me. The one that really can't yet is continuations. And the ability to suspend myself, give the user an object that represents my state so I can continue it later. And Microsoft for years has gotten away with not needing it because we have a message loop model. And the message loop model says you make all the state explicit and you pass it around to everything. And it's a state-based model, and it's very side effecty and doesn't work with these other functional type models. So somebody's got to make a decision about which way we want things to move. And unfortunately, moving off of the message-based model is a real problem, because the message-based model, as we've done, well, as everybody's done it, puts a lot of state on your thread. And that means things can't move from thread to thread, and that reduces the amount of parallelism available to you. So I think there's some fundamental underlying platform things that have to change. I think it'll be a big change. I think it's going to happen, but it's going to take a long time. And on the language side, I think we've actually got the ideas in there. The time is right to start doing it.
Dave?
If you I'm sure since you use some kind of search engine, you heard that some search engine company called Google And if you read any of the papers, they use something that many people come and say, running, what is this new MapReduce stuff? MapReduce, well, that's actually, most design patterns are really just the things that functional programmers have been doing for years. And MapReduce is a data parallelism technique, just as Jim was talking about, that goes back to the functional programming community. That's a very natural way to do it. The other things that you're seeing now are what are called sort of shared memory or transactional memory, or that come from like Lambda tuple spaces, for example. And there's another way, which used to be called a monitor, and then it became an actor, where you actually, instead of getting on this naked thread and peeing and being on it all the time, having to do semaphores and block and tackle and all these cruel and unnatural acts, you actually unify the message passing with the actual encapsulation, and you get these things that are called actors or something like that. So you can actually have active behaviors.
Do you recognize the guy who's second in line?
Yeah. I'm doing the setup.
Carl Hewitt, who invented the actors, happens to be the second in line here.
Okay, so any more comments here?
I was going to say, we actually had the kind of structure you're talking about in Monad in a very early version of the language, just because people are very used to it. When shells run processes, they run in the background, they run concurrently, that sort of thing. And we ended up pulling it out because when you're running everything in the same memory space, then you get all this complexity around synchronizing access to an object. And for the average shell user, that's like, okay, no. We couldn't figure out a way of coming up with a safe semantic without adding so many locks on our own that nothing would run in parallel anyway, so why bother? And so in the end, we pulled it out. Well, yeah, sure. I mean, get your average sysadmin to sit down and start doing some functional programming. Yes, sir, I'll get right on that. Although, really, I mean, if you look at the way shell scripting works, piping from one to another.
Pipes is just function programming.
Pipes is exactly right for functional programming, but we don't do functional programming, so pipes don't work.
Programming. Okay, so can we have the next question here? Or maybe some lessons?
Oh, no, I have
Wisdom?
no lessons. I just have stitches. I just wanted to pick up on the thing that you said about the future. So, which sort of my student Henry Baker and I invented LODES many years ago. And there's an issue here in the dynamic languages. The dynamic languages tend to have this extra level of interpretation in between. So if you had a future on something, okay, they can cope. But if you say int, okay, the CLR is not going to be happy with the future for an int. No way. It wants an int. It wants the bits right there. So there's a tricky runtime issue there and what to do about that. I just wanted to mention that. But thank you for a wonderful panel.
And thank you, Carl, for so many of your wonderful ideas that we're still trying to implement.
That's right.
Moore's law.
Okay, so thank you very much. So is there any other questions, or can I kind of continue with my continuation here?
Sorry about that.
So when is it? The schedule says it's until 10:30. So I'm happy to kind of continue as long as there are questions. And sorry, 10:15. Okay, good. So we have 15 minutes. So if you want to have some questions, better kind of get ready. So let's go.
The one thing that I think we started touching on a little bit with the IDE conversation, and to sort of put a humorous subject to it, text-based languages are so 20th century. If you look at like the workflow models, or if you look at state diagrams, there's a lot of times where when I'm thinking about the problem, I'm not thinking about text, I'm not thinking about sequential statements. Where's the Microsoft work in terms of, even being able to do non-von Neumann machines with like FPGA generation, where I don't have to be locked into a sequential CPU architecture, I can do more fluid type of programming.
Well, so I can start with, the first thing that we need is for somebody to take this program called LabVIEW, which has this wonderful visual designer model, and port it to be one of the next .NET languages running, so that, sorry, I'm joking. That's one of the guys who works on LabVIEW, which is, I think, one of the good tools that does capture some of this stuff. And so part of the answer here is, there doesn't necessarily have to be a great Microsoft answer in this space. I think there are some places that we're doing interesting things, but getting the visual programming model out there is, another one that people can work with in this space is wonderful. there are a number of things going on here. You saw some of the really cool workflow. And did you see the workflow demos in the keynote? You know, all of that is running, again, as another .NET language, and it is a graphical .NET language, but it plugs into all the rest of this infrastructure and has the same good properties we've talked about here, in that it works with all of what we're talking about, and you can stick a Python script in your workflow if you want to, you know, or extend it in VB.NET. So it does play with the rest of it, and it has this whole visual debugging model and all of that that you're looking for. And then there's, you know, there's other projects going on to try and extend that workflow stuff and, you know, do a general purpose visual programming there, which is really cool.
I just, you know, my role as, you know, senior faculty member here or something, I'll say once again, look to the past. How many of you know the language Logo? Yeah. Okay. Well, that's interesting. So the guy who one of the guys who founded the Logo stuff is a guy named Hal Abelson, who also went on to do Scheme, and also went on just about, oddly enough, 20 years ago now, to a language called Boxer, which was a visual language for Logo that explored the space very nicely. And, you know, I just look at my 20-year clock and thank you for pointing out another one of the things that the researchers had 20 years ago and is just getting ready to go. Now, the problem they had at the time was anything having to do with recursion. Loops were fine. Recursion, they never got a good graphical design for, especially where they were not self-recursions, but cross-recursions and things. And there's a lot of interesting explore space there. I think it'll come.
Just as an interesting note, as Jim mentioned, I work on the LabVIEW program. LabVIEW was invented 20 years ago, so the clock continues.
Right, so I heard it mentioned that you guys were considering, you know, making functional languages more of a primary goal. And in Microsoft Research, you guys have done F#, which is, you know, OCaml implementation. So are we going to formalize that, make it actually something that's productized, or are we just going to have to go find it by navigating through 500 web pages to get at it? That's question number one. Question number two is that I actually come from a slightly different background than the rest of you lot. I'm actually a Prolog programmer. So,
is this like an AA session here?
I accept your condolences. So one of the things that I've found is that, you know, I've now implemented a WAM in probably about 10 different languages at this point, and the latest in C#. And I heard it mentioned, of course, you know, wanting to formalize the concept of an AST. Well, in Prolog, that's a slightly different idea, in that what we're really looking for is an exemplar and then trying to unify that. So what is your comment there, and, you know, what can we do in the CLR to make that more interesting?
So I have two comments. One is, I'm sorry because these are going to be not particularly positive, but I am on the public record already for having said that when we started the design of the CLR, we explicitly looked at logic programming languages and explicitly said they were simply not of sufficient interest to make them a major concentration. So it wasn't an accident, and it's not an oversight. The other is, 20 years ago, as part of my PhD thesis, one of the things I showed was that you could implement Prolog's placeholders using the same mechanisms you need for futures. So if we ever get to futures, you'll actually get what you need for the fundamental underpinnings. And then I believe then you'll have everything you need. But Carl was exactly right. I didn't mention it, but the problem is in a static, in Scheme we got futures not quite for free, but close to free, because it is a dynamic language, associated with everything at runtime is its data type. And so we simply made future a data type, and then anything that needed an integer was already checking to see that its arguments were integers, and it was throwing an exception. So we simply caught the type mismatch exception, which you don't get in your static languages, except when you do casts. We caught that and automatically went and grabbed the value out of the future, and that made the whole system work, and you got all this beautiful parallelism and data flow through it. You can't do that conveniently in a fully statically typed language system. So I don't know how we're going to reconcile those, but to me the odd thing is I think we're going to get to Prolog being a good first-class language because we're going to do the parallelism. And if you did a Prolog right, it's got to be on an immensely parallel machine, because all Prolog is about is combinatorial explosion of a search path.
Right. I mean, that was satisfying.
Yeah.
I think if Eric ever, you know, if you should take Eric out for a beer, because, you know, anyone that's so lazy as him Delayed evaluation. Of course, that the same machinery you need is exactly the Haskell machinery. And if you look at some of those holes and things they have in these new kinds of expressions, those tricks are going on under the hood. So I think that I would suggest that sometime down the road there should be a way to bring these together. Certainly, as soon as you have that machinery, you can implement things like that.
Any more questions?
I would just say that with generics, I think we can have like future T and have a reasonable implementation in the future of futures. I've seen that kind of implementation for C++. And it's not the same thing, but
Yep. So can I interject one question before, because now we're talking about generics, which was the last thing. Actually, most of the questions kind of corresponded with the ones that I had here, but
a mind reader too.
Yeah, thank you. So generics. So this is another idea that's 20 years old that's now showed up. But the question is, is generics a good idea, and especially a good idea for dynamic languages? Because with generics, the types are all in your face, right? If I have a generic function, then I have to pass the type parameters, etc. So, what is your opinion about it? Like, say, Jim.
So first of all, the good news on generics and dynamic languages, which is, because the CLR implemented generics with all the runtime information kept around, it means that these dynamic languages can work with them, incredibly well. There's about 5 lines of code in IronPython that make it understand generics and work effectively with the generic infrastructure and use reflection to sort of tie into it, and then we're done. And even all the code generation that's going on is generating the right code, because all the types are sitting around there at runtime. So I'd just say if you're designing a VM to work well for dynamic languages and you put generics in, you probably want to keep the type information around at runtime. Probably the wrong audience to tell that to. The other side, though, of calling generic methods from these dynamic languages, sometimes it can work extremely well when you can do various kinds of inference or generate the right sort of proxies. So you pass your list. Somebody expects a list of string, and you pass your list of object to it. You can generate a list of string that then each time you pull out an element, it checks that it's a string. You get kind of the dynamic behavior, and you can kind of make the two worlds work together. But there is certainly a bit of a mismatch between the two. The other thing that my real major objection to the fact that we added generics to C# and VB comes down to, I used to love to put up slides about why dynamic languages were so much better than static languages. And one of my favorite slides was to show collections and to show this fact that, if you're going to create an array list and you're going to stick all of these random things in it and then you're going to cast the elements on the way out back to string, well, this is just silly. You should be using a dynamic language because your static languages can't actually keep all the static stuff, and they have the runtime checks anyways. And the horrible thing is generics have taken that particular arrow out of the quiver for why you should always use a dynamic language. But,
Dave, do you have anything to say about generics?
I mean, it's a hell of a lot of work for as yet an unknown benefit. I mean, in the sense that you could have had full dynamic languages and a lot of power, and then constrained that, through the system, and we put an awful lot of work. And in Java, it's a disaster because they disappear. They don't exist at the runtime, right? So it's not clear at all. I think we're going to have to. I mean, talking to Gilad, he's the same thing. I mean, who knows what the hell a star type is, right? So it's not clear that we're going to know how to use these for anything other than the kind of textbook examples. Like, people do lots of nice things with stacks, but the real people use these very often. Not at all clear to me.
Okay, so I think the last question is for you.
There was an earlier reference for FPGA, and I was hoping to get comments from you that how you will manage all those tens of millions and trillions of transistors that you have in FPGA. That what kind of programming language you could have to do a nice management of those future things. No comments of FPGA.
You win, you stumped the panel.
What, sorry? Sure, go ahead. So now we have an answer from the audience. Good. That's a nice. Why don't you go to the microphone there?
You have to introduce yourself.
Yes.
So my name is Michael Rees. I'm what some people would consider an ex-query bigot, although I think...
So you're going to say X-query is the
No, no,
way
no,
to
no.
do FPGA programming?
This is not the answer. First, the reason why I think I can say a little bit about it is that when I did my PhD, I was at ETH, and Niklas Wirth was doing research into languages for FPGA programming, etc. I think so there is research in that area, but I think the problem with FPGAs in the general area is that they are too expensive. So, well, for the last 10 years, yes. And so the problem there is just that given the cost-benefit ratio, I think it will be very hard to see any major development there outside of that specific community. And that's why, yeah, I think if you haven't looked at, I'm sure you have, look at this stuff that Niklas Wirth did in like the mid-90s or so. You will see some interesting stuff, and probably there has been more done after that. But
see, mid-90s isn't 20 years yet.
No,
not yet. So that was like 95 or so.
Yep. And also, of course, Haskell is the answer. If you look at a library called Lava, which is a functional programming library where you write, MapReduce, filter programs, and they get, translated to VHDL and then to FPGA. So Haskell is always there. Look, 20 years back, yep. Okay, well, I think we are at the end of our session. I thank the speakers, or the panelists, very much. Thank you as the audience for the great questions. And I don't know when the next PDC is, but I hope at the next PDC we'll have another language panel and that you will all be there again. Thank you very much.